Our civilization runs on energy. Every advancement, every innovation requires massive amounts of energy to function. As our technological prowess grows, so does our thirst for power. We are constantly searching for new and efficient ways to satisfy our energy needs, looking towards renewable sources like solar and wind power. But what if we could harness the power of a star? This is the extraordinary idea behind the Dyson Sphere, a hypothetical megastructure that encompasses a star to capture its immense energy output. Imagine a sphere of colossal proportions, enveloping the sun and capturing every photon of light it emits. Such a structure would grant us access to energy on a scale never before imagined. The Dyson Sphere is not merely a science fiction fantasy, it is a serious concept explored by physicists and engineers. While the engineering challenges are immense, the potential rewards are too great to ignore. The Dyson Sphere represents the ultimate solution to our energy needs and a potential pathway to a future of unimaginable abundance. The Dyson Sphere is named after physicist Freeman Dyson, who popularized the concept in 1960. Dyson himself was inspired by the science fiction novel Star Maker by Olaf Stapledon, which featured a similar idea. However, Dyson's contribution was to frame the concept in a scientific context. In his paper, Dyson argued that any sufficiently advanced civilization would eventually need to harness the full power of their star. He proposed that a civilization with advanced technology could build a massive structure around their star, capturing its energy. This structure would be detectable from Earth, as it would emit infrared radiation. Dyson never intended to propose a specific design for such a megastructure. He simply argued that its existence would be a logical consequence of a civilization's increasing energy demands. The idea captured the imagination of scientists and the public alike, becoming a staple of science fiction and a subject of serious scientific inquiry. Our current energy consumption is minuscule compared to what a Type 1 civilization, capable of harnessing the energy output of its planet, would require. As we progress through the Kardashev scale, a measure of a civilization's technological advancement based on energy consumption, our energy demands will increase exponentially. Fossil fuels, even with their detrimental environmental impact, are finite resources. Renewable energy sources, while promising, have limitations in terms of scalability and efficiency. Nuclear fusion, often touted as the holy grail of energy production, still faces significant technical hurdles. A Dyson Sphere would provide a permanent solution to our energy needs, granting us access to a virtually inexhaustible power source. With the sun's total energy output at our disposal, we could power our cities, industries, and transportation systems with ease. The possibilities for scientific advancement and technological innovation would be limitless. Types of Dyson Spheres, from swarms to solid shells. The classic image of a Dyson Sphere is a solid shell completely enclosing a star. However, this design poses significant engineering challenges and may not be the most practical approach. Over the years, scientists and science fiction writers have proposed various alternative designs, each with its own advantages and drawbacks. One of the most popular concepts is the Dyson Swarm, consisting of numerous smaller satellites orbiting the star in a dense formation. This design is more feasible than a solid shell, as it would require less material and could be constructed incrementally. Another concept is the Dyson bubble, which utilizes light sails to create a static sphere around the star, held in place by the pressure of solar radiation. The Dyson ring, a less ambitious but more achievable structure, involves a ring of collectors orbiting the star's equator. Each of these concepts offers a different approach to capturing solar energy, and it's possible that a combination of these designs could be used in a future Dyson Sphere. Challenges of construction, a monumental undertaking. Building a Dyson Sphere, even a smaller scale version like a Dyson Swarm, would be an undertaking of unprecedented scale and complexity. The engineering challenges are immense, pushing the boundaries of our current technological capabilities. One of the primary challenges is the sheer amount of material required. Even for a Dyson Swarm, we would need to dismantle multiple planets, perhaps even Mercury or Venus, to gather enough raw materials. Then there's the issue of transporting and assembling these materials in space. We would need advanced robotics, self-replicating machines, and perhaps even space-based manufacturing facilities to accomplish such a feat. Another challenge is energy transmission. Once we capture the sun's energy, we need a way to transmit it back to Earth or other colonies. This would require highly efficient and long-range energy transfer technologies, perhaps involving microwaves or lasers. The technological hurdles are significant but not insurmountable. With continued advancements in nanotechnology, robotics, and materials science, we may one day possess the tools to embark on such a monumental project. A future powered by stars, the promise of the Dyson Sphere. The successful construction of a Dyson Sphere would mark a turning point in human history. It would signify our transition to a Type II civilization, capable of harnessing the energy output of a star. With access to such vast amounts of energy, the possibilities are truly limitless. We could power our cities, industries, and transportation systems with clean and sustainable energy. Space travel would become commonplace, and we could establish colonies throughout our solar system and beyond. The advancements in science and technology would be exponential, leading to breakthroughs in medicine, material science, and computing. The Dyson Sphere represents more than just an energy solution. It represents a future of unimaginable potential. While the challenges are significant, the rewards are too great to ignore. As we continue to push the boundaries of science and technology, the dream of harnessing the power of a star may one day become a reality.